And good morning, good afternoon, and good evening, everybody. Welcome back into the Dragon's Den. My name is Digital Dragon. I'm a 3D printing variety streamer here on Twitch. What does that mean, you might say? Well, it means we do everything from unboxings, kind of like our X1C carbons here or Prusa Mark IV, to modifications, full up printer builds like our Vorons, our Annex Engineering K3, the black box build, the rat rig that's sitting down here on the floor. Do some prototyping, such as the closed beta for the Zero G Mercury 1 full frame build, the Trad Rack, and what we're working on today, which is the Box Turtle by Armored Turtle. The Box Turtle is basically a open source AMS-like unit. Um, I think you've got the AMS by Bamboo Labs. You have the Creality, I think CMS, the Creality Material System that's coming out. You're going to have one out by Anycubic. There's something out there by CoPrint. You've got the 8-track by Armored Turtle, and now we're going to have the Box Turtle. So you may say, well, what does the Box Turtle look like? Well, this right here is the CAD for Box Turtle. Unfortunately, I'm not allowed to make the files available, but I can show you the representation. This is the CAD render here. Um, some changes have been made to the system, or are being designed. Let me rephrase that. There are some changes that are being designed, and I'm not sure if they're going to be a straight replacement or if it's going to be hey, you can either do this or you can do that. In talking with Armored Turtle yesterday, or actually over on Discord, he did want me to point out a couple of things, and that will be the on our lanes, each one of our lanes. Remember how we printed these separate and then we added heat set inserts and then added these on. The whole reason that it's done like that is to keep each part within a 220 by 220 build area, because that's what you're going to be limited to for things like a Ender 3, right? And so, one, this system fully works. It just requires a little bit more hardware. And two, um, we may be looking at an option where these are built in, but you'll have more snap away supports. So that is something that may be in the works down the road. Um, but the primary goal is functionality first, and we'll start doing some more of those. Good morning, Mr. Wizix. Hey, KB3D Chris, welcome on in. Thunder Keys. You're getting your Dunkin' Donuts and prep for the stream. It's a sad morning. I've got no Dunkin'. So for those of you that don't know, we had a family medical emergency with my mother-in-law, so Mrs. Dragon left. So I got up smidge skosh late today and didn't get to head out and get Dunkin' unless I was willing to push the stream start back. And Thunder Keys has been promoting me all over the place, so I can't really throw new time in there. So, morning Shadell, morning Hybrid Robotics. Hey K2, how's it going? Hey K2, I don't know if you saw these or not. Them pop out, but there we go. We have been doing purple for the wings and for the flower petals, but Mrs. Dragon also wanted some of the silk rose, so I'm doing some of them in silk rose. But thank you so much for helping on that design. I really appreciate it. Um, oh, No worries, Thunder Keys. It's all good. It was just one of those things. You know, as we get older, um, we have parents that are also getting older, and so then we have to help out when some things happen. So, it is what it is. Um, yeah, thank you guys. So good news is uh, my mother-in-law is out of the hospital. She's into rehab. Like I said, she took a fall, and uh, she's good enough, and we're in a position where we got a call Wednesday night, Thursday morning. Flights were booked, and he was out that afternoon. So no worries. Yes, Pesliz, they are lovely chips. I appreciate you guys working on those for us. Trying to get Mrs. Dragon. I mean, she was close. She was really, really close. But thank you for some spit and polish. I'm trying to get Mrs. Dragon to do a little bit more on the 3D printing side, and she's been harping on on maker chips. Been seeing them at Rocky Mountain and seeing all mine. So. Oh, sounds good, Pesliz. Yeah. So, um, everybody, everybody, come on in close. I need your help because I can ramble, and we can do 6, 7, 8 hour streams on Saturdays. I need to be done by 2, okay, ish. So if we're going along and all of a sudden my mic cuts out, just start saying, "Hey, fix your mic and sign off." I got to drive up to Virginia. I'm going up to my brother's house this afternoon. My mom's 80th birthday is tomorrow. So, and yes, for those of you that have been asking, this is my old merch. Um, the Stream Elements site is shut down. Thank you, Stream Elements. They have us over at Fourth Wall. Um, I've got to redo these designs. The dragon will stay there, but the digital dragon font and everything is going to have to change. So that's why shirts and stuff like that aren't available at the moment. I'm working on it. I promise you, I'm working on it. Oh yeah, Kevin. They last year you couldn't move. I mean, you were there. We couldn't move really, and it's going to be that way. It's going to feel uh, kind of like Rocky Mountain was for their inaugural day, right? Um, so with that said, um, also soon, once Box Turtle releases, we do have stickers that some people have made. Darn reflections. Get out. Collecting stickers and lights. So we do have Box Turtle stickers as well as shirts. They're not available for the public, I don't think yet. Are they, Thunder Keys? But several of us are going to have stickers at the show. There's going to be several Box Turtles at the show. I'm going to have 2 out there. I don't know if they'll be hooked up. At least one will be hooked up to a machine, but I am going to have 2 out there. Um, and I think we're going to have them at West 3D, Fabrico, KB 3D, my booth, and we're trying to get one out at Polymakers and a couple of other places. So, yeah, we're going to have them all over the place. You made them public? Awesome, Thunder Keys. So, if Thunder Keys, if you want to just throw some links in there for the shirt and stickers, that would be great. We're just trying to get some hype up. So, I found in stops, right? We were looking for in stops. I found in stops. They were in this nice little pretty case sitting right on top of my screw case, my Screwfinity, the same Screwfinity that I've gotten into like 6 times on the stream. Yeah. They were sitting right there. So I was a little annoyed. And you may see that things are cleaner over here on the side. That is because I am in preparation for um, taking that bench down, and there'll be, well, like, yeah, this whole table here, like everything's cleared out from underneath. There's just a few things sitting here, and I'll probably go right over here on the rat rig when I build the table for the rat rig. But I was told it was going to be here Friday. Didn't come Friday. I was told, or excuse me, Thursday. I was told it was going to be here Friday. I was, we went to Micro Center in Charlotte, came back, was told at like 3:30 it was out for delivery out of Greensboro, mind you, an hour and a half away. I was home by 4. By 9 p.m., I had a notice from DHL dated April 30th, 11 p.m., that my package, that nobody was home when they tried to deliver my package. And I had signed for no contact delivery, so they didn't need me here to sign for it. So why the hell they didn't leave it on my front porch? Don't know. So it's coming on Tuesday because Monday is a holiday here in the United States. So it'll get here Tuesday sometime. Not real happy about it. April. Did I say April? I'm sorry. August 30th. Yeah, you know what I meant. Everybody know what I meant. Haven't had enough coffee yet. Bear with me. Be nice to me, Tugboat. I know I owe you guys stuff. So Tugboat, you actually, sorry for all the screen changes, but Tugboat, you missed the last stream. But this right here is what we're working on assembling today. The box turtle. Um, Let me go ahead and turn it around here because this is the back side. There's an option for 4 filament paths or a 4-into-1 hub. So we're doing the 4-into-1 hub. There's options for using extrusions as the vertical uprights, printed parts that have cutouts for LEDs, and there's a new one for just a solid corner. Turn this around. There we go. So this would be the front of the unit and your 4 lanes. These are LEDs right here in the front. Short little pieces of PTFE tube with a little guide nub. And the front wheels will be driven by N20 motors, really tiny, small motors, right? The rear idlers are just they're freewheeling. There we go, freewheeling. And then in this design of it, there's a little lever here that will allow you to move the rollers in or out. So if you're dealing with, say, like a sample spool size, you can make it shorter and run through your samples. Okay. What else? The black wheels here are TPU. So it'll be a TPU sleeve over a printed part. There's a trick to get these on in this design. I haven't tried the new design yet. What I do is I just heat this up slightly with a heat gun so that I can get it in there because there is a taper to this wheel. That's why trying to get it in there, this is the bigger end, and this is the shorter end, or the smaller side. So a couple of things there. Okay, now let's go ahead and get started. Where we left off on Thursday is we did a lot of prep work. Okay, we got all of our heat sets in place on the parts for our front spoolers. We got our um, bearings in place here. We got some ECAS fittings pushed in. We got the small guide bearings put in. So this would be where the little piece of PTFE tube and the nubbin goes in. And this becomes your first sensor, which is whether or not the lane has filament in it. So you'll put your filament in, it'll go between these two tiny bearings. And when it does, it'll push this out and force it to rock. When it does, this lever releases the end stop that's going to be mounted underneath here, and it'll start the extruder motors to load the filament in. Your filament will then go into, you'll have to manually push it all the way through until it hits the gears in your extruder. And once you hit the gears in your extruder, it's going to take it out until it trips this filament sensor that's right in here. As soon as it trips that, it'll stop, pull it back slightly, and now your lane is loaded to the extruder. Okay. And then you'll have a sensor at the hub, so it'll know if one of the lanes is uh, if the filament's broken in between the hub and the um, tool head. So what we've got to do now is we ran out of end stops. I couldn't find the rest of my end stops, so we only built 2 of the extruders. We need to build the other 2 extruders this morning. We're going to wire up some end stops, and then we with with all the soldering out, we'll go ahead and wire up our lights. I already have all of my light to light jumper wire and my longer length um, wire here. And we'll go ahead and do some soldering. Once we're done there, we'll start putting together our front respooler pieces. We'll have to do a little bit more soldering for our motors, and then we'll just keep tricking on through here. Good morning, Cruising Girl. Welcome on in. That over out the way right now. So first thing on our extruders, I do want to finish wiring up a couple of end stops. What did I do with the end stops now? Are you kidding me? What did I do with the little container that had the end stop? Right there. Okay. Here we go. I am using 24 gauge wire for all of the end stops, for the LEDs, for the N20 motors. Okay. And then for the communications between our MMB, this is a Big Tree Tech. I think it's multi-material board is what MMB stands for. But this was designed for the Enraged Rabbit Carrot Feeder or other things. You can use this for trad rack. You can use it for whatever you want. It's 4 motors and a bunch of in stop or sensor thing. It does have a dedicated port for a motor, a sensor, and lights. And by motor, they mean servo. So we'll use this board here, and we'll have communications between this board and a MOSFET. So this is a, whoops, MOSFET. Sorry, here we go. Let me just do. Okay. Apparently I need. So this is a MOSFET. I think you can get this off of like Adafruit, Pie Shop US, Pie Hut. And what this is, you'll have 5 volt and ground coming in. you'll have 4 signal wires and a ground, and then each of your N20 motors will connect into here. So this is how we're controlling the respooler motors at the front. The motors for your extruders, your NEMA 14s, are being driven off of your MMB. And don't go and get 5160s for this. Get your standard 2209s. There's no need for anything super crazy here. So just kind of a heads up there on the circuitry. So we need a total of 9 of these. We'll go ahead and do 3 of them now. The other 4 we'll do after we get our lanes kind of built and ready, or when we start doing the front lanes. Up with it. There we go. So the way we knew this is all 5, or the 4 extruders and the hub, it's going to use a ball bearing to trigger the end stop. So we don't need the levers for these. When we do the e-spoolers, we're going to need the levers left on there. So how do we deal with them? Well, you can buy them with levers and you can buy them without. For me, it's just easier to buy them in bulk with levers. And then you can squeeze the 2 ends together here and just do like a little twist motion, and the lever will come off. And you just toss that over there, leave it in case you break one of these, or you need one and all you have is the bare ones. You have the levers, you can put them there. Also, remember on these, we are soldering these ones up as what are they normally? Normally closed. So the outer 2 pins are what we're soldering up. The pin where the plunger is the common. The center pin is normally open. The pin farthest from the plunger is normally closed. So we're going to do common, which will go to ground, and then the normally closed, which will go to the pin, PA2, PBC, whatever, on your board. So what I'm going to do is I'm just going to set these in here in my OmniFixo. The nice thing that I like about the OmniFixo, other than the fact that your clamps can move all the way around, you can stack them up. The clamps are straight horizontal, right? So as I open that up, it gives me a straight full clamp. So if I'm putting a end stop in here, I can put the entire end stop in there and get a clamping force across the entire end stop. If you're using the helping hands that just have the alligator clips, one, if you've got the alligator clips, they have teeth. So if you're trying to hold wire, you can actually cut the insulation on the wire, which will cause a short later on. Or you go through and words are hard sometimes. Or it just, yeah, you can damage wires. Your part really just has a surface or two where it's actually touching, so it moves around a lot. These have been a lot better. They're expensive, but they work great. Okay, so what we're going to do is start with our wires. We figured out the wires just by doing simple guesstimate measurement. I believe somebody has been working on maintaining a list of wire lengths. I think Thunder Keys was. I keep meaning to sit down and do like a rough estimate, but it's going to depend on whether you're using an MMB or an AFC light board, which is going to be a custom board to work with this. So Jemison, yeah. I know I saw somebody had been. You don't need a huge amount stripped off here, just a little bit. Probably about 2 millimeters or so. We'll go ahead and we'll get our soldering iron plugged in. Get our solder ready. Oh. So in the past, I've used the thicker solder. And I think it just takes a little bit longer for it to heat up and stuff like that. I've switched over to this thinner gauge solder and it works a lot better. So especially on these smaller electronics pieces. Folks, I'm going to sit down so I can get a little bit closer to the solder and keep my head out of the way of the light as I'm doing it. Okay. So all we're going to do first is just touch our solder to the tip, get a little bit on there, dab the excess off. You're just basically retinning the tip and making sure you've got a nice solder area here. We're going to heat up the outer legs and just apply some solder in there. And all we're doing is pre-tinning these legs. So it'll make it easier. We're going to pre-tin the legs of the end stops. And then we'll do the same thing for our wires. We'll pre-tin those. We'll go ahead and take this one off as well. This is going to be for the hub. We've got to do some rough measurements here, but if you give me 1 second, we'll go ahead and get 3 of these set up. We'll have to figure out the wire for that one here in a second, but we'll do the 2 so we can do the extruder. And one of the reasons I like stuff like this is I can set my solder wire just kind of up in a loop like that. And then I'm going to take my soldering iron. I'm going to start heating up my wire and then go up and touch the solder and help wick that solder into the wire. Now that wire has quote unquote been pre-tinned. Now we're just going to take that, sit it next to that leg, heat everything up. And boom, we've got a good connection. Same thing for the other one. Heat the wire up first. Touch solder. Doesn't take a lot. Then we're going to come over here and line our wire and the leg up. Apply heat. Take the heat away. Wire's connected. Okay. And yes. Same thing. We're just going to do these other 2 wires, and these will be the last 2 end stops for our extruders. So we were having this discussion earlier. If you're going to build one of these, there's going to be a bomb. Actually, I think the bomb may be available now, or soon for Patreons. There we go. Or you can watch through here and see everything that we're using. Um, Wiring, I use 24 gauge FEP wiring because it's a lot smaller. If you use a silicone wire, your wires are going to be thicker because of the insulation. Okay. Um, so a downside to that will be less, or your wires are going to take up more space, which will make it a little bit harder. Um, as you can see, these hold their shape a little bit better. Silicone wires are very floppy. So some people find routing FEP wire easier. Some people find routing silicone wire easier. To me, it's going to come down to the application because each one has strengths and weaknesses as far as the application goes. So what I'm doing here is I'm just kind of setting this down here because this is going to allow me to gauge. These are the 4 lanes. They're going to make up the box turtle. I know my hub. So these are the front. The cutouts are the front for the respoolers. So my hub's going to be back here, right in the middle. So I'm going to need to bring wire from the hub around, up one side to the MMB. So that tells me that I need a little bit of wire. So, but that wire needs to be able to go from here to the corner, around the corner, and more towards the front. I'm looking for rough estimate here, doing a Steve Builds rough estimate, by looking at the printer and kind of just roughing it out, giving myself a little bit of room to play with in case I have a bad crimp and I have to cut off. Or we'll call that a service loop. And I'll just get my wire together, get a second wire cut. And what we just did was the 2 wires that we're going to need for the end stop for the hub. That'll be the third end stop we're going to do here. Once again, I'm using linear wire. I get this from KB3D. You have an affiliate link that you'll see pop up in the stream. I have been told that there may be limited stock. You don't have all the colors. All of my end stops, I'm using black. The lights, I'm using black, blue, and red. Red for the 5-volt, black for the ground, and pick a color for your signal. I do it specifically for those because if I get an end stop wire backwards, I can go in and add or remove an exclamation point in the software. And no harm, no foul. It still works exactly the same way. If I get a whatchamacallit wrong, if I get a power signal wrong on the LEDs, they go poof and they no worky. And then I'm taking things apart and resoldering stuff. So just where, I mean, if you buy these things in a large spool, then you're going to have some wire for a long time. Be careful of getting FEP wire through Ollie. Look for, as with anything on AliExpress, look for a company that has a lot of sales of the product, because that means that, I mean, there's only so many, I'll say, suckers that get taken with a bait and switch and a crap product before it gets out and people start being warned away from a company, right? So just be cognizant of that. Okay. So once again, we had already pre-10 this other end stop. So we just need to do these wires. We're just going to heat up the wire some, then touch the solder, just to get a little bit of solder in there and it'll wick into that wire. Then we just line it up, apply some heat. And hold it in place till it cools off. Hey, Westry, how you doing, sis? How are you doing? We are doing some wiring right now. Um, Trying to get our box turtle wired up. All right, so there we go. Got those three done up. Now, while I've got things right in front of me, I'm going to scoot this to the side and I'm going to bring this. This is a jig for wiring up the lights on a Enraged Rabbit carrot feeder. I'm lining them up with the pads going perpendicular to this tray. Normally what you would do is line them up with the pads going in order, and you're going to solder them with these little gaps. And these printed ridges here are made to stick your wire down into and hold in place to make it easier to solder. So what I'm going to do here is I just got 3 of my 4 LEDs in here. I'm going to do the initial inbound. Then it's going to go out of this one into this one, out of this one into this one. Then I'll move it around and add the 4th one. And I'll go out of this one to the 4th one and we'll be done. Okay. Now, when trying to tin these little solder pads, I use some Amtech. This is NC559B3TF. It's flux. So I just dab a little bit of this. It helps the your solder to flow. And I'm just going to go and put just a tiny dab on each pad. And I have found that wiring up my lights, this helps tremendously. And once again, you don't need a lot, you just need a little dab. And I know that the camera is kind of far away. I was talking about that with Evil Diesel yesterday as we were over at Micro Center. And I can't bring myself to buying like a $700-800 printer right now. The streaming rig, we just when we were out there yesterday, I broke down and upgraded the processor and memory for it. So I did do the processor upgrade to the AMD 5900X, the Ryzen 9 5900X. And the memories, I went from 32 gig to 64 gig because I'm doing some more fusion and having some more complex fusion models up. So, oh no. Oh, just your yearly checks? Okay. Said vet. I was like, oh no, what's wrong? So now what we're going to do is just apply a little bit of heat and solder to all of these. And it'll go by pretty quick. We don't need a whole lot, just a tiny bit. You're just looking for like a little ball there. And that flux is going to help keep that right on the pad. So that's why I'm using the flux, is it's going to keep it right on the pad. It'll kind of like bubble up like water on a windshield. And that way it doesn't merge and you basically solder across the pads. Really need to build one of those fume extractors. Got all the stuff to do it from Alien. I just need to do it. Okay, so there we go. We now have all of our pads pre-tend, and we're going to double check and make sure they're all in the same direction, meaning the inputs are closest to me, the outputs are further away from me. Okay. And with them all lined up in the same row, then we go 5-volt signal ground on all of these. So once again, it's going to make it easier for us to do our wiring. We're going to go ahead and strip the ends of uh, our ingress wiring, is what I'll call it. We won't strip the other side of these yet because we'll do that a little bit later when we go to put a connector on it. Okay. And just like before, we're going to start off with our 5-volt, which will be our red wire. We will pretend this wire. Downside of FEP wiring is that sheathing, because it's so, I mean, it's basically PTFE tubing, right? Because it's so smooth and slippery, trying to get um, a good clean strip of the insulation is. Now we're just going to take this wire, set it down on that pad, and apply just a smidge of heat, and we'll get that pinned on there, soldered on there. Oh, come on, you little jerk. Apparently I didn't get that. There we go. The one done. Next up is the signal, which I'm going to use blue. Just use some other color. Normally you can get these in a wide range of colors. Quick application of heat. That's right, I didn't tin that. That'll help if I tin it. Let's try that again. Short application of heat. What's going on there? There we go. Same thing for the last one. If you start to get a little bit of a buildup, just clean your tip off. Okay. So that's what we've got right there, our first 3 wires. When we go to do our next wires, we want them to be coming down in the same direction and loop back around. So we're just going to do a U like that. So when we go to do our next set of wires, after we pick up the first wire or the first light that we just dropped out, move things back, get all these set back in here. Okay. We're going to need a blue, red, and a black. And we're going to strip both ends of this now. Because we're going to connect the out to the in. Hey, Steve Builds, how's it going? Glad you made it in here. We are doing some soldering and soldering up some LEDs. We are building a box turtle, which is an open source AMS for the most part. Got one of these built downstairs. It's sitting on the Trident 350. I need to update the software on it since they did some updates recently. But yeah, it's just too many things going on. Like I said, we were out of town over at Micro Center most of yesterday, so. All right, Pezliz. Have fun with your sister and brother or sister and brother-in-law. We're just going to pretend this wire heated up. Melt some solder to wick it in the wire. Do that on both sides. Clean off any excess. And we're going to go ahead and do the positive side first. Going to the output pad, and then we're going to come over here and go to the input pad. Okay, then we need the signal, which is going to be our blue wire. And there's another reason why I'm definitely using 3-colored wire to do this versus just doing black. And that is because on the MMB, the Big Tree Tech MMB board, the RGB light is the only connector in that set of connectors that the ground is in a different position. So as soon as I get this done, I'll show you what I mean. Ah, he's a coffee lover. Okay, good. Brother-in-law. Okay. The nice thing here is it does not take much to get these wires attached as far as heat or anything. So once again, this is what we're doing. We have the inbound that are going to be coming from our board to the bottom side of the light. Then we're connecting from here to the bottom side. We'll do the next daisy chain and go from the top to the bottom. We'll move things over and then go from the top to the bottom on the last one. Now, on the MMB, talking about our wiring and stuff. In fact, I'm going to move these over now. Maybe not good that way. Down in there. Thank you. On our MMB, every single one of these ports here, the ground is in the middle pin, except the one RGB slot here. The ground is at the bottom and the signal pin. So the signal and the ground is reversed on the RGB port for whatever reason. I don't know why. They didn't consult me. I would have assumed that ground was one entire plane and that 5-volt would be one entire plane, like the 5-volt is, but yep, those little gotchas. And you need to make sure which version of the board you have. So this is a version 1.0 board. If you've got a 1.1 board, there is, and I'll have to pull up the schematics, but one of these, I think it is STP3 or STP4. The pin for this and your first motor driver enable pin are reversed. Meaning on one, this pin is the motor and this pin is the end stop. On the 1.1 board, they're reversed. So you got to know which one you're working with and verify. Trust, but verify. All right, there's that one. There, this is the fourth one. I'm going to go ahead and get this set in here as well. And these pads real fast. Cover. Power. So we did some of the preliminary work on the first stream, which was going through and doing a bunch of heat set inserts. Then we started doing up the end stops, and then I couldn't find the rest of my end stops that I knew I had. So then we started putting together a couple of the extruder motors since we had the end stops for them. Now we got the rest of the end stops uh, wired up here, at least for the extruders and the rear hub. We'll start building our respoolers. We'll have to wire up the um, motors. Okay, so we'll grab our positive wire and we'll go through and start tinning and getting these set up. Wanting to run away from me. As you start getting these on there, it starts getting a little heavier and it keeps pulling the lights out of the little jig. Again, I'm repurposing the ERCFA jig here. See if I get. Hey, old Diesel, how's it going? Come on, fingers work. And I've either had not enough coffee or too much right before soldering. So if you've ever done LEDs for like a stealth burner, this is basically the same thing that you're doing, playing fun here. And I always do that. I always So we only need, on the last one, you only need the inputs. You don't need the outputs unless you're then also going to daisy chain LEDs for the corner post. But be careful on, I don't know how many LEDs you can put together on that 5-volt leg. But I think it's 5-volt, 3 amps is all the board's good for, but you're also running your N20 motors off of it. So you got to be mindful. Now, can you also just add another cable and link stuff back to the Raspberry Pi or the main board on your printer? Yeah. All right. So Evil Diesel, I haven't done, I didn't do any like benchmark metrics or anything like that, but it's definitely uh, faster as far as loading things like OBS and Fusion. And of course, it's using up, I don't want to say it's using up less memory, it's using up a smaller percentage overall because, well, we doubled the memory in. I also got my Raspberry Pi 5 set up with the NVMe. Yeah, that's what I said. I haven't done like any benchmarks testing, and I didn't do any benchmarks against the old setup, so I can't comparatively say, well, it was increased by this much. Um, I can tell you that it is a noticeable difference. I went from a Ryzen 7 3700, which has 8 cores, to a Ryzen 9 5900, which has 12 cores. And then we upped the memory from 32 gig to 64 gig. So no more paging out or anything like that. So I've shut the soldering iron down for now. I'm going to scoot this over to the side here. Trust me, I burn myself often. Um, One thing that you can do, because we were just using flux on this, um, quickly look for the little cap that we had that we dropped. You need to just get like a little rubber stopper and eraser or something like that. This tube of flux, by the way, is going to last for a long time. But you can just take a quick paper towel, You can use, depending on what you're working on, a Q-tip. All I'm going to do is get a little bit of alcohol on here and wipe the backs of these down. It's going to get rid of any of the extra flux that's on there. Just clean up the board a little bit. You can do this after you do the initial tinning. It just kind of gets some of the sticky off from the flux. But there's our daisy chain of wires that are going to be the lane indicators. Okay, we're just going to take this and set it aside for now. We're not going to need it for the time being. But I figured since we had the solder out, we'll just keep soldering up. And we'll have to do 4 more end stops, but we'll hit that when we get closer to it. So these were the end stops for the next 2 extruders, and this is going to be for the hub. That over there. Okay, so our extruders. If you were here for our last stream, you'll kind of know we needed our end stops. And, ooh, I forgot to put heat shrink on these. Let me do that real fast. Probably not as critical because there's really nothing as metallic it's gonna hit, but it will actually help strengthen the joint as well. Yeah, no video codec processors. Yeah, I'm planning on just using it as a server, and in fact, I was doing some research on things to set it up as like a development server. I need something I can tinker with, and Raspberry Pi running NVMe is going to be a lot quicker than. Where the heck did the other? There it is. It'll be a lot quicker than a Raspberry Pi running on SD card, and more reliable because NVMe is made to be read-write where SD card isn't. One of the downsides to the Raspberry Pi is you will start to have random weird errors. And that's normally an indication that some part of your SD card is dying. And yes, a Odroid, a Jetson, or some of that other stuff would be good as well, but and I'll tell you, I'm impressed with the Libra boards with their eMMC memory. Where did that piece go? The eMMC memory is pretty snappy as well on those. I am going to get the heat gun out for this, because I know we'll have some more a little bit later on. Make quick work. Okay, we got our heat shrink on there. Feel a little bit better now. So now that I got my heat shrink on there, I am going to kind of give these a little bit of inward tilt and figure out which way this is going to go and get my wires kind of bent back just a little bit. Okay. And we're going to start by feeding our end stop wires through the extruder. We're going to need a 5 millimeter ball bearing. This is 5 millimeters. The Enraged Rabbit carrot feeder uses 5.5. So you can't just use like a kit from there. You're going to drop it down, and there's a kind of like we see here. There's a spot for that ball bearing, and it's closer to the extruder gears. So that's where your plunger needs to be. So your plunger on your end stop is going to be on the inside here. And we're just going to pull that end stop in and through. It's not fully seated. Don't worry about it. We will get it there. Because the next thing we're going to do is take this little printed piece, and it's going to slide right down in the grooves there, and we're going to push that down in there. And then we'll use some M2x6 button heads. I'm sorry, not M2x6, M2x10 button heads. Or not button heads, socket heads. Darn it. Whichever ones you got. I think I have a mixture here. These are button heads, so that's what I'm going to use. Button head or socket head, whichever one's called out in the BOM, whichever one you actually have. It's not going to matter here. We don't need a button head for the size or anything. You're screwing this through a plastic part, through the holes in the end stop and into plastic. So just use your fingers. As soon as you feel the resistance change, you're done. Keep going. You're going to strip stuff. Did you compare SMUF versus the ERKFA? I have never built a SMUF. I thought about it. I still may at some point. I never built an original ERKFA. I've got an ERKFA V2 downstairs. In fact, that's where that MMB board came from. But I've never got it tuned. I've always been chasing issues with it. Whether it's primarily it's the servo. And I've got the upgraded servo in it. So it's dealing with servo stuff. Have a good one, Pez Liz. Have fun with your family. Okay. So we now have our end stop installed down there. Guess where we're at it, we'll build them both side by side. So we'll go ahead and get this one started as well. And you don't need to do much. I just find barely pulling the legs in just helps for whatever reason. We'll get that started. We'll drop a 5 millimeter bearing in there. Bring our end stop into position. Grab our little pusher piece here. Make sure it's orientated in the right way. The holes are offset to one side. Push that down in there with your pinky. Grab a couple more of your M2x10 button heads. Like I said, button heads or socket heads won't matter. Yeah. because the Smuff was originally built um, for Marlin, and then it's been extended out over time. And I believe the Prusa MMU is based off of the initial Smuff work, wasn't it? Like the original Prusa MMU. Okay, so end stop on both of my extruders is in place now. We'll need our little extruder packets. We clean up my little step shavings here. So I'm going to dump the contents of my extruder packets right there and build them. And once again, we've got a bag inside of a bag. There's going to be certain things that we won't need right off the bat. This. Somewhere I've got the other baggie of spare extra parts. Figure that out. So we're going to need our big gear. Already got one of the bearings on the back side of it. Our clamps. We're going to get rid of the little O-rings on our ECAS fittings. And once again, if your ECAS, you take your O-ring off and your ECAS looks like that, where there's no black at the bottom and you can see the metal, go ahead and stick everything back on, then take just the O-ring off. You need that little black plastic piece there. So, the little O-rings, I don't know why I've been keeping them for the time being. I don't know if I'm ever going to need them for anything. Somewhere I had the, oh, there it is. And then whatever extra parts are in here. So we're going to have our tension knob, tension spring, and big washer at the end, the retaining washer. Have the clips there. We'll have the ECAS fitting pieces. We're going to have a drive gear. We don't need that. We'll need the drive gear that may or may not have the set screw in it. You may have loose set screws rolling around. We're going to have our needle bearings and the idler gear. We'll get that prepped there. And you'll have two shafts. We're going to use the shorter of the two shafts, but the longer one we will use for something as we build this out. Let me grab my syringe of EP2, because we will need that as well. Coffee. So, where do I want to start? We'll take the one bearing, and that's going to go down here on the thicker part of our extruder. And this is going to be the front end of our big wheel. Now I'm using my large shaft because I can get fully in there, and that way I'm going across all of the outer and the inner races. You never want to push. Let me grab a bigger bearing. Actually, a 608 will be easier to see. Oh, no. I just dropped my tiny bearing on the ground. Oh well, that was lost. I think it went up underneath the rat rig. But on a 608 bearing, good one. So you want to push on the outer or inner race. You never want to push right in the middle. So by taking and there's a little ridge there. The inside is where the bearing is. So if you start pushing like right there where the black is, you're going to mess up the bearing itself. If you come across the race and push down, um, you're distributing that downward force across the races, and you're not going to damage anything. So that's why you're seeing me use something long that I can get across both sides of that bearing race. So we've got that bearing pressed down in there. We're going to need our motors. So we've got one of our motors. And you want to make sure that your wire is kind of coming up to the top and not the flat side where it mounts. And like I said, that normally on our motors, the wires are coming directly out the side, right? In this case, it's doing a 90 and coming up the side of the motor versus out from the side. So put your wires on first and just deal with the floppy cables. So I'm going to set this on there. We're going to put a screw through here, and then the other one is over here. So you'll see that this is a slot for adjustment, and this is basically the pivot point. So we get our motor in there, lined up. We're going to use a M3x8 socket head cap screw. Don't crank it down. You want it to be able to move some, right? Get a little bit of movement there. We'll go ahead and get our other M3x8 screw started. Once again, don't crank on it yet. We want it to still be able to move freely in there and do its thing. Okay. Now, I find it a little bit easier to do my drive gear before I put it on the shaft. So when you go to do your drive gear, you need to take the set screw out, put a little bit of Loctite on it. In this case, I'm using a Loctite paste. Thanks to Steve Builds for showing me that. There are some applications where the liquid is better, then there's other applications where the paste is better. So you probably want to have both. And make sure you get this lined up on the flat of the shaft. And we don't need to yank and crank on it just yet. Now, every single one of these I've found, just take it all the way to the plastic piece, right? Bring it all the way down to the plastic piece. Chances are that's going to be the correct position. You might have to move it just ever so slightly, but we'll verify that location. Oh, I'll show you where I run all my motors, and I think it works pretty well. So you're going to take this bearing and get it down in that hole. Just line it up, and it should go in very, very easily. It shouldn't take a lot of pressure. If it's taking a lot of pressure, you need to check your tolerances. Okay. Now what we're going to do is kind of manually by eyesight line up our teeth, and we're going to rotate the motor. We're just going to pivot that motor around so that the teeth engage. And we're going to hold the motor in that position, and we're going to manually move our motor just by moving this whole shaft here. And what we're looking for is very minimal play between going one way versus the other. There will be a little bit of play. If you jam this motor in there too much, you're gonna bind it, right? And it's gonna have to work harder to move this big plastic gear. So what I do is I kind of push it in, let it off, and then just barely hold my finger there to hold it in place and work it around a couple, 3 times. And that'll let it find its sweet spot. Now I'll take your 2.5, and I start down here with the pivot, locking that in place. And then I'll lock the other joint down. And once again, we'll check it, make sure there's no play, and that's where we want to be. Now, you're going to want to make sure that your set screw is pretty much facing right up. And this is where we're going to marry the 2 halves. Now, you'll notice that there are 2 spots here for keys in the printed part that are going to line up with the slots in here. So we're going to just line this up, start moving this into the shaft. We'll get our keyed spots together, and boom. That's exactly what we're going to be doing. We've now got our extruder parts together. We can flip it over, and we're going to do some M3x8s to hold this together. The biggest screw that we use on this build is M3x8. You will see me do some M3x6s instead of the 8s sometimes. I do that just because I'm running out of M3x8s. I've got some on order. And some of these locations, an M3x6 is perfectly fine. You're going to get at least 3 threads into the heat set insert. So, and it's not a, like I could use M3x6s here. It's not going to impede the functionality of this screw holding this part together, right? And it saves me some M3x8s that I can use. My M3x8 should get here today, so. Okay, so there we go. There's our extruder. Now we still need to do our idler. And before we do that, we want to take a little bit of filament. Always keep some little drag around that you can use for alignment purposes. And we're going to go through our hole here. And it's going to go through the gear. And first off, when you're putting that filament in, listen for the click. Okay, that's telling you that your ball bearing is triggering the end stop and you're good to go there. You're going to push this through and take it all the way through. And what you're doing is looking to make sure that the gear is lined up and meshing with your filament. And what I tend to do is just kind of loosen the set screw, wiggle back and forth some and let it find its natural position. And then I'll lock that set screw down. Now your gear is locked and the filament is in the right position to drive the gear. Okay. Idler wise, our idler is going to sit in there like this. And this is going to become the pivot joint for it. So set your idler on top Once again, easy thing for me. Set the idler on top, flip it over, set it down. Now you know which way your idler has to go in order to engage with the drive gear. We're going to get our finger underneath there. Once again, we've got our two needle bearings in here. We're going to put some EP2 grease in. Kind of fill that up. We're going to take the shorter of the two M3 shafts and start feeding it into those bearings. Once again, holding the other end with our finger so that no grease can squirt out. As we start shoving this 3mm shaft in, you're going to see that needle bearing start to pop out. That means the grease is pushing the needle bearing out, which is what we want. We're going to use one fingertip, one fingernail, push that back in and hold it flush. You'll see that this just moved out a little bit. Now I'll use the other finger and push the shaft in until you feel it in your, in my case, left hand finger. I'll remove my finger and put the shaft the rest of the way in. Now you'll see there's a little bit of grease sitting out on both sides. We need to clean that up, being particularly mindful that on the side that the filament goes in, we don't want any of that grease to get in that filament pathway. If you get grease in the filament pathway, then you're going to have some issues down the road. What am I looking for? Another paper towel. There we go. So I'm just going to push that the rest of the way through, clean off the excess grease that came out. The other side, I'll just push, do the same thing, kind of push your thing through, grab the excess grease, line up with a little bit of room on each side, and that's your idler. Once again, look at how the gears on this one, so the filament path is facing me. So that's how this one goes in the idler, with the filament path facing me. Push both sides in. There we go. Now you can just set this right on top. We're going to need a M3x30 button head. So M3x30 button head, and this is going through the body, through the idler, and into the other body there. And this becomes your pivot joint for your idler. So once again, finger tight only. Going through plastic, so just finger tight only. Once you feel the pressure it takes to turn the screw change, you'll know that the head has buried out and stop. Right? You want good movement here, because at some point, if you need to, for maintenance purposes, you're going to want to lift that open so that you can get it jam cleared, right? Then we're going to take our tensioning arm and to set the pre-tension on this, I always take it all the way tight. Okay. Now I'm going to grab hold of that and I'm going to turn one full turn. Now I should be good. We need to do our ECAS, and I'm going to grab my Knipex pliers. Because what we need to do is stick our blue piece and the gray piece. So using our Nipix pliers, which are smooth jaw, we'll line this up, make sure it's centered, and just slight gentle squeeze. And the blue piece will pop in there. No problem. Well, it doesn't when you're on stream and it makes you look bad. How many did we do of these on the last stream and not an issue? There we go. So that's one end. Just make sure that it, it does its little pneumatic plunger thingy. Get the second one set up. Okay, so 2 plungers working. Now, unfortunately, there's not an easy way to do this one. You're just going to have to get it lined up and great as possible. Give it a little push. And if you need to, put it down on a hard surface. Push it till it pops in. Now we're going to do the same thing on the other side. We got our 2 ECAS fittings. And everything's working. So we're going to take this extruder, set it off to the side now. After I put this back on. So this will be what I mean with the way these go on there. It's kind of a pain in the tuchus to get this wire in there. Because the weight of the wire keeps wanting it to bend out of the way. That way. There's number 3. Number 4 is up. We've got our end stop started. We're going to need the last set of our gears. And I dump them out on a paper towel because with the hard surface, I find that they don't go running off on me on a paper towel, but on a hard surface, they're gone like yesterday's news. Hey, look, spring's already on there for me. Grab our retaining washer. That part's done. Take the drive gear, toss it over there. We're not going to need it. Long shaft, we're not going to need it because we still have the other one there. Take the rubber donut off of our ECAS. Throw those over in that baggie. I don't know why I'm keeping them. Like every design that I've used says take the donut off. I don't know why I keep them. Did you get the hardened gears? I probably not, Nick. This is generic AliExpress, like $1.80 gear set. So I'm pretty sure that if they said they're hardened, it's a lie. So here's the thing. It would only matter if you're running like a lot of abrasive filaments. So luminous, glow in the dark, wood, or of course glass or carbon fiber filled filaments. But just like with the AMS, you probably don't want to do that because one, you'll drive grooves in the bearings that are used for the inlet sensors. You'll tear up your Bowden tubes. And yeah, when we get to the Bowden tubes, you'll see that will be fun. And yeah, you can always swap the gears out later. It's not Doing things with the extruders is relatively easy. Doing things with the respoolers, more of a pain in the butt because these are mounted in the lanes. The lanes are mounted inside the extrusions. So in order to do those, you have to take the corners off, rotate the extrusion out of the way. Now you can lift the lane up and undo the screws that are holding it to the lane, right? That's where I'm saying probably, PLA, ABS, your like galaxies and stuff like that. I have yet to mess a gear up running a galaxy type filament. And if you do, you've put a lot through it. I mean, it's just normal wear and tear on gears by that point. Okay, so that's there. We need our other motor. Again, we'll get this lined up. In 3x8. But everybody says, oh, PLA, no big deal. Yeah, watch out for your glow in the darks. Your luminous will probably do it as well. Your UV reactive will do it. And wood filled. And once again, it's because they're doing the glow in the dark and stuff. I believe it's titanium that they have to use to do that. And it's that titanium powder that's in there that will cause the abrasion, right? So once again, you want this to be able to pivot and adjust. Open it all the way up. We'll need to get this is our idler, so get our needle bearings put in there so they're out of the way. And since I got it here, I'll go ahead and just do the grease fill. Okay. Shaft. Put your shaft in there so the bearing starts to poke out. Hold the bearing in place, push the shaft the rest of the way in. And what that is doing is forcing all of that grease into the needle bearings. Wipe any of the excess up. Include off your little finger there. And that'll be ready to go into our idler. Our drive gear, we need to pull the set screw out. Put a tad bit of Loctite on there. And I'm not sure, if it's going to be worth going out and getting a, $30+ set of Bondtech gears for all four of these. Um, put it in your extruder. Save your money on these. If you want hardened gears, then you can go out and get just the hardened gears themselves. Um, once again, polished or what have you. Put that in there. Turn it and make sure that you're not dragging on the printed part. You should have enough room that you're not dragging on any part of the printed part. Get your initial gears pretty much lined up. Push your motor gear in. Then, like I said, I'm just going to rest my finger against it so it can move a little bit, but I don't want it to move a lot. And then I'm going to turn the shaft front and back. Make sure I don't have any backlash and I'm not I'm not really, whatchamacallit, I'm not binding. You can tighten that motor down. We're going to take our two halves now, put them together. Again, using the keyways to keep everything lined up so that you're getting that shaft onto the other bearing. And then fold this over. And like I said, I'm going to try an M3x6 here. I think we're going to have plenty of thread to get into our heated inserts. Oh no, that one, there's not too much there, so I do have to use the 8s here. We used some 6s in a couple of places already. Just because I'm waiting for Amazon to show up and I'm literally running out of, well, let me rephrase that. I'm running out of M3x8 black screws, and I'm trying to keep everything the same color. You know, color coordinate. That sounds good, Nick. So, whoop, I guess it'd help if I do my filament check. So we're going to make sure that our in-stock clicks. It does. We're going to load our filament in. And I don't know if you can tell here, but there is just the slightest gap, if I can get it, between the plastic part and the gear now. It's all we're looking for is we're using the filament itself to make sure that that gear is properly aligned. And then we'll lock down the set screw. We can pull that filament out. Set our motor down there. Put our idler in there. Open it up. Now that we're looking at this and looking at this, we can take our idler gear and put it in the right orientation. Flip it in place. Okay. Just set it in the slot there. We're going to need our M3x30. Hey, Roland Nomi, good morning. Hope things go well this coming week. Well, they should. I don't know why they wouldn't. That's working well. We're going to take our tensioner. Oops, if you put it in a straight orientation. And like I said, I found a good initial pretension on these. It's just tighten them down and then one full turn back. And that gives you pretty good tension. Now we need to add our ECAS fittings. So we'll grab our Nipix and Okay, both those are set. We'll get those pre-started. Push the rest of the way in. And there we go. We've got our 4 extruders. While we're here, we'll go ahead and grab our last, whatchamacallit, sensor, which I didn't put thingies on this one either. So let me real quickly put some heat shrink on here. So this heat shrink tubing right here actually came with a set of end stops. That's why I'm continuing to use it, then go dig around for some others. That was too short now. Oh, she's being mean to red. Why is she being mean to red? Why are you being mean, sis? Like I said, the heat shrink is going to, 1, protect the solder joint, and then 2, add a little bit of strength to it. Okay, so once again, we're going to need one of our 5mm bearings. We're going to just drop it in there, let it find its hole. We're going to take our end stop, making sure to orientate the plunger right over that area. We're going to grab another M2x10. And once again, we're screwing into plastic and right up against the side of the end stop. So just be careful that you don't strip things out, that you don't split your end stop housing as you tighten this screw down. Yeah. You have to use a standard 2x10 self tapper. That just kind of hit a dead end and said no more. So let me grab a standard M2 or M2x10 self tapping screw. And I prefer the socket head type here because um, the button head ones are just so freaking easy to strip if you get dubious quality ones. And then um, same thing with the Phillips head because the heads are so small. But the self tapper will have a point on it, which will make it a little bit easier to get it driven into plastic here. There you go. And just like before, we will take a short piece of, I think we're done with gears for now. Gears totally. Um, Take a piece of PTFE. Now we ran it through there without the ECAS fittings. All we're doing is listening for the click. So my filament's running smoothly through there and I'm hearing a click every time. So we're good to go there. Set that off to the side as well. Now let me think about what we've got left. Lanes, got that. Need to put together our respoolers because if we don't do that now, it becomes a pain later. And my 10 shafts, they didn't fit the bearings very well. So I did have to go through and um, sand those down. I did that off stream. So, hey, MG Longshot, how's it going? Your ASC light board? Okay. Yeah, the ASC light boards. I need to get one of those. By the way, folks, I didn't make the announcement, but we are in September, right? So for the whole month of September, um, any level 5 hype train, or once we get 10 gift subs, or 10 subs, resubs, gift subs, 10 subs, every 10 subs within the stream, I'm going to be doing teaspoonfuls of spoonfuls of the Pex Pepper Spicy Habanero Salsa. Okay, so this is something that's going on all streams for the month of September. This stuff is really good, but it says hot and it means it. It's tomatoes, jalapeno, habaneros, red onion, lime juice, salt, and cilantro. So I do have this sitting here at the bench. So if and when one of those two conditions are met, we will be doing some salsa. Okay, we're going to start doing our spoolers. We're going to need one of each side. We'll need our centerpiece and our lever. We will need one of these, a shaft, and wheels. We haven't done the wheels yet. We're also going to need a tool, wheels, 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 wheels. How many wheels did I make? Now these are the old style wheels. There's 4 wheels. 4 of those. So that's one set. We're also going to need some gears. So we'll need a big gear and a small gear. Three big gears, 3 small gears. For decorative shafts. Those others are for the back. Why did I print 2 sets of wheels out? I printed 2 sets of those wheels out. And I printed 2 sets of the new TPU wheels. I didn't print the actual the other parts of the wheels. Well, that's great. So interesting. I may swap those off stream. We'll see. Or maybe not. I probably won't. So, what thing I found, and we explained this earlier. So, these wheels are tapered, right? So, this is the inside, this is the outside. We go back to the overhead view. Inside, outside, there's a slight taper to these wheels. Your TPU covers that go on here have that same taper, and you've got a captive ring on one side that's on the big side here. Trying to get these two things in doesn't work very well, right? So what I've done, and this is a suggestion I made to the group, use your heat gun, right? You're going to take your wheel and just gently warm up the TPU. This is the old style. That is correct, Nick. And as I do it, I'm just going to continue to move the wheel around just so I can kind of feel and gauge. Doesn't take much. And it becomes easier, a little bit more pliable and easier to get the piece in there. I say that, and then you don't want to do it too much. You just want to do it enough that you can get it started. And they do have to go on there the right direction. If you don't get them in there the right way, the rest of the wheel, there we go. So now you've got your wheel. Now, this side has a flat. This side has a conical shape. That's because your end cap has that same conical shape that's going to fit in there. And it's also got that lip that goes around the inner side. So it's kind of a centering piece. That's going to be one side of the wheel. So now we'll just do the rest of them. There is a new wheel style, and like I said, I just realized I've got the TPU prints. I did not print the actual hubs. So I apparently thought I did, but I didn't. I just made 2 sets of wheels. Um, Now, there is a little seam there that you might be able, you see it right there in the light. It's not going to matter on these particular prints. Um, Depending on your printer, um, some people have found that using the new scarf joints helps. Also, heat it up, put the center hub in the wrong way, push it back out. Seriously, push it back out. And what that'll do is expand it just a tiny bit, which will make it easier to get it over the lip of the wheel. Hopefully before it cools back down. And then you can snap it in there. So there I've got 4 wheels. Those are extras, so we'll toss those back there. So we've got, wait, what am I thinking of? I do need a total of 8 of these, don't I? There's like 2 on each side. So I'm just being an idiot and can't count or think. So we do have to do 8 of these. I don't know why I was thinking, oh, there's 4 lanes, 4 wheels. Four, four, four. Okay. And then on the other side, we'll have a little different set of spools. So we'll get all of our wheels going. Yeah, they're a little bit easier to put together. That is true. And you want to be careful here that you don't like melt these completely when you're heating them up. Because then they'll be a loose fit on the wheel, because once again they're tapered, and basically we're opening one end up to allow the fatter end to go in, or we let it cool down too fast and we do it over again. And it's probably also going to matter what type of TPU you use. This is Polymaker, so it's what, 90, I think. Dang it. There we go. There's 2. The new wheels don't have that rear lip on it, and it does have some built-in like chamfers on the end to keep your spool a little more centered and keep it from running off the side. And you want to keep this moving around. That's why I'm like pinching it a little bit and moving it, because by pinching it, it lets me know when it's starting to get a little bit more pliable. It'll make it a little bit easier to get on the hub. There's our 4 sets of wheels. We'll need one for this build. We're also going to need our N20 motors. That's something I was forgetting about, which are going to require us to do a little bit more wiring, or soldering. So we'll get that ready to go real fast. N20, there we go. So before we start doing this, let me move this stuff back out of the way, because I want my lanes again, because I need to do some quick, simple mental math. Okay. So this is the front. My MMB goes on my MMB goes over here. So my MOSFET is over here towards the front. Yeah. So I'm going to have a motor right here. So that tells me that I need to run my wires, say, from here. Which way did I go? Hold on a second. Let me do this real fast so I can visualize some. My mouse. Oh, my mouse die? All right, give me half a second, folks. My mouse died on me. And I'm going to need it. There we go. We got a mouse back. I'm gonna hide the. Here, this is what I'm doing. I'm gonna take a look at the CAD, and I'm gonna hide the bottom panel. And now kind of let me see where I'm at here. So this is the underside. I've got our lanes. There we go. In that same order. My MMB is over on this side now. So my MMB is to the left. My MOSFET is going to be in the right. And all of my motors, I'm going to run along the front edge. So let me. Nope, that's what I want. Okay. So my lanes are laid out in the same orientation that the CAD's showing, right? My respooler motors are up here at the top. My MMB is going to be over here on this side. My MOSFET is going to be mounted over here. So think this will be like here. My MOSFET will be right here. So I need to run, this is lane 4. So lane 4 is going to go here. 3, 2, 1. So that's going to give me an idea about how big I need to make my wires. And I'm just going to cut one wire in black right now because I am going to do black and red or black and something. I'll most likely just keep it black and red. Um, and I'm going to give myself a little bit of extra here. So there we go. There's our black wire. That's going to be our ground for the motor, DC negative, I should say. And then we'll need another color um, just to signify which side's the positive versus the negative. So let me come over here and grab my 24 gauge red. Run that because once again, this is motor power. I guess it's technically positive and then signal. Um, and all we're going to do is just make these equidistant. So one set, darn it. Hey, Waken, thank you for the follow. Appreciate it. And once again, this is a um, box turtle. This is a closed beta product at the moment, but we are showing it off. We will have several of these on display at East Coast Rep Rap Festival. So if you're going, you'll be able to see one of these in person. Could have several, not just visible, but running at the show as well. And I believe at this point in time, we're going to have them at West 3D, Fabrico, uh, DLL, PDF, I believe. West 3D, Fabrico, KB3D, DLL, PDF. There will be one at my booth. So yeah. Okay, so now that we've got that, I'm going to get my boards back out of the way, and I'm going to move these back over here out of the way. We need to do some wires real fast on our motors, and the positive side of these are marked. So we just need to figure out which one is the positive. We'll get all four of these set and ready for positive, and we'll do the positive side, and then we'll do the negative side. Now on these motors, the easiest way to do the motors will be to strip a little bit of extra wiring, and you can, there's a little eyelet in the motor so you can stick your filament through the or your filament. You can stick your wire through the eyelet and then bend it over and then solder that joint. So that's how I'm going to do these. We'll just strip a little bit. And my positive are all on the left side here, so we'll strip a little bit, get your wire twisted together. Through the eyelet, and then just bend it back on itself. So, whoop, there we go. It's going to be kind of hard to see, but this goes through the eyelet. There's a little hole in the eyelet, so you can get it through there, and then we'll solder that whole thing as one. And I'm just going to get all of my wires set and ready. Oh yeah. Like I said, I've got one downstairs that is already up and running. Apparently I need to do a software patch that just got done yesterday. And then keep keep testing with that one. This one we're building on stream so that people see the kind of the build. And eventually what we're liking or what we're looking to do is try and get some kits or at least some like bomb in a box kits um, from the major people like DLL PDF already has frames, so you'll be able to go out to DLL PDF and get frames. But we're also looking, and I say this like I'm like one of the main team, but I'm not, just a tester. Um, they're also looking to get, like I said, some either West 3D or KB 3D, Fabrico, all of the above, to have kits for these. We think that this is going to be well received by the community. I'm hoping it is. I know I was glad to see it, and I cannot thank Rob and Thunder Keys enough because Thunder Keys is the one that threw my name in the hat, and Rob was all for it. I don't know if Rob remembers, but me and Evil Diesel were at the table next to him at uh, Rocky Mountain. So it was Edge of 3D, us, and then you with the BattleBot arena right behind me and Edge of 3D. And like I said, I'll tack these down real fast, and then we'll set up and do the black wires. Same dance, you know, apply heat, apply solder. And we'll go through and do the same thing, matching up the length with the same length of the other wire. Correct. Correct, Wakalith. It is very, very reminiscent of a AMS. In fact, one could say it is a open source AMS, um, or you got what the Creality CMMS, Anycubics. I don't even know what Anycubic is calling theirs. But funny enough, I have not seen or heard much of Creality's endeavor, and with Stratasys being Stratasys again, I'm not sure what's going to transpire there with Bamboo and what it will do trickle down wise to um, like Creality and Anycubic, right? And I don't think we'll have any issues from Stratasys like on this because it's a design, right? It's not going to be like a pre-built commercialized product. So I think that's what they're really going after is the Chinese manufacturers that are popping these things out because I I didn't see him go after Prusa, right? If you've read the if you read the Stratasys stuff, I'm sitting there reading that going, well, why didn't they go after Prusa? Prusa's been doing all this with the MMU for years. I mean, everything except the RFID and some of the software claims that they were calling out seemed to address things like MakerWorld and the software aspects of it. And I'm like, well, the MMU, yeah, it doesn't have the RFID tags, but they've got PrusaLink, they've got Prusa Connect. You kind of went after that functionality in your lawsuit against Bamboo Labs. which is part of the reason why I say hopefully it gets thrown out wholesale, because it feels very much like they're picking and choosing who they go after. Right? It feels very much like they went after the Chinese company and not the others that are playing in the game. And it could just be that when they were playing in the consumer space, Stratasys wasn't concerned. But now that they're going to come out with the X1E and supporting more technical filaments, now it's getting into their bread and butter. All right, Wester, you want to get involved in law speak. How goes the studying? For those of you that don't know, my sister from another mister, aka Westery One, is planning on taking the bar somewhat soonish. All right, doing outlines one subject at a time. Okay. Okay, 4 motors. Hopefully that's all the soldering for now. We'll have 4 more end stops to do, but we can add those after these are built and installed. I'm going to leave that right there just like that. Grab one of our motors. We'll add it to our pile of things over here. So, we're going to start by using our gear press here. Put one of our larger gears in it. And it's completely flush on one side. The other side has a little spacer. That little spacer, does it go towards the bearing? Actually, I believe so, thinking about it now. Yeah, it needs to go towards the bearing. Hey, Maker Viking, how's it going? So when you put your gear, it'll go in the little spacer lip is going to go in towards the bottom. You're going to take your shaft, and I didn't check those. Dang it. I might need to ream these out some. 8mm shafts. So we want a 8mm reamer. I'm going to do this by hand. Those are size good. Okay, so we'll start off again. We're going to take our gear with the little flange piece. We're going to flange side down when we put it in our helper. We're going to take our shaft, push it in until it bottoms out. That's setting the proper distance down the shaft for our gear. Okay. Now, yeah, I'm like, I just had a brain fart. This is going to go on the left side, or the side with the single registration mark. The other side has 2 registration marks. We'll need one of our centerpieces. Actually, shaft will go there. That's not looking right. What's wrong here? What do I think? Oh, no, that's right. That is right. That'll go in there. This will go in here. Should go on there. Really? Fine. Good God. Our decorative covers. Sorry, I was hearing something beep. And I didn't use these on my last one. They are a spacer though. That was tighter than I thought it was going to be. I do need to ream these. It's a spacer, not decorative. Yeah, I know. But I was like, the reamer went right through, so I don't understand. But it's a circle, which we all know 3D printers do not make circles, right? They make a multi-sided shape because 3D printers don't do arcs. No CNC machine does. There's an arc plug-in that will help it get closer, but a 3D coordinate system does not do arcs. All right, so what am I going to do with this now? Kids, don't do this at home. Be better to use a hammer. Also, a bit more. That there. There we go. That's on there now, spaced right. All right, brain's not working. I'll go in there like that. Our motor has a D shaft on it, and we want to press one of our drive gears onto that motor, or onto that D shaft. Get it lined up appropriately. I get it started, and once again, be very careful. You don't want to bend the shaft or bend the motor. What the hell is making that noise? These ones are tighter than the first set. Or screwdriver. Yeah, I follow the Ivan Miranda something here that's banging against each other. So what I try and do is to get this printed part like flush on the shaft, and she's not going on there this time. My previous parts went on just fine, so either the shaft's a little bit bigger on these, or same printer, same print tolerances, just a different filament. And I definitely do not want to hammer on this. So let me grab my Nipix. I don't think that'll get long enough. We'll grab our Nipix and go very slowly. Like I said, you do not want to bend this shaft, or you're going to have a bad day. I'm going to have to get the large ones out. Make sure that you're nice and straight. Go slowly. Once again, we do not want to bend that shaft, or it'll kind of not do what we want it to do. Yeah, come on. one, that's what we're looking for, is for it to be flush right with the edge there. And your motor is going to sit right in here. Okay, and that's where this piece comes in. It got a tab, locks in that hole there. And is going to hold that motor in place. Once again, these are M3x8 screws. Don't think it matters in which orientation you put the motor in. Oh yeah, the Nipix pliers are awesome. And this piece, once again, there's a slot here that rides in this slot, and this gear is going to mesh with this gear. So that's what we're trying to do here, is get the gears meshed and get it in the slot. Now, from the looks of it, I don't have the distance, so this has to be further down on the shaft. How is that going to work? I mean, I know how it's going to work, obviously. How do I press that the rest of the way down? Do I just move the motor deeper in the gear? Or, yeah, why not do that? Why don't we loosen that, push the motor back more in the housing here. Not providing much in the way of clamping force. And I mean, there are slight indents here for that gear. So okay, there we go. So we're lined up shaft with the two gears. Whoops. All right. And there is one M3x8 that'll come in this way that'll connect these two pieces together. Do my magnets. Guys, let me not do my magnets. Let me do magnets real fast before I forget. Where do I have magnets? Actually, I'm going to be nice. Grab. Open. If you can do this and that magnet's not coming out, then okay. If you can do that and the magnets are coming out, you're going to want to use super glue. I always put them in like that, and then try and get it pressed on the other side or mark it or something so I know which way the magnets go. Does not technically matter if they're all going in the same direction, as long as these two on each part are magnetized towards each other, you're good. Like, where'd the other arm go? One short. Grab a 6x3. I tend to buy these in bulk as well. And I tend to also just leave a round or a set of them sitting on my bench. That way I always have them available. So when I put the first set together, both sides of these were using the 2 keys. Now there's one on one side and two on the other. So it pretty much helps align it in the right way. Now we're going to feed that around. Going to go on the shaft, and it'll press up against the everything, and our motor wires and motor will slip right on through just like so. And everything fits together just like that. So we'll have another M3x8 down here at the bottom. Now you don't want to crank down on these too much because once again, this piece right here, and that is what was that, a 25, I believe? Let me look at the CAD real fast. Wheel, side. M3x25. See, I'm used to having them behind me. Now I gotta come over to this way. This is an M325 that comes through here, and this is the pivot pin, basically. So once again, we're just getting it in there because this needs to be able to move, right? If this doesn't move, then you need to loosen these pieces up because you've got too much side-to-side friction in there. So this needs to move. So yeah, that's it. Now we would press on our wheels, and your wheels are going to go on there, and you're going to have this hub. Get that one started. Good God. So what I should have done was reamed out the wheels as well, because now they're going to be on there. The motor wires stay inside the spooler now. Okay. Oh yeah. And you're telling me that because I need to. I will have. I think I will have room. If I can get the M3 by 25 screw undone. I think I will still have room. I'll take out the M3 by 8. You've literally got zip ties there, huh? Ay, ay, ay. Um, 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 um. Am I going to have the ability to get these suckers back off, or at least one side back off? And that answer is probably no. So yeah, these there's a cutout now for them. I completely missed that because I forgot there were some changes to the printed parts. I really should have reamed these. What I'm probably going to do with this particular one is I'm going to go put it in the freezer for a little bit and see if that will help it loosen up a little bit. We'll see. Hopefully that'll help and at least make it a little bit easier to get these back off. So bear with me one second and we'll do it right on the next one. Nothing like having to put parts in the freezer. Okay. Now, before we go any further, we're going to pop those out, and I'm not going to be able to do these by hand. Where did I put mine? There it is. All right, what the hell? Like something at my desk is making a beeping noise. And I cannot figure out what it is. And I have a feeling it's something that's vibrating. So notice I'm doing the hubs and not the ends because the hubs will hopefully slide on there a little bit easier and the ends will definitely have enough oomph and hold to hold on there. Okay. Now, let's start again. Another set of parts. Big gear, little gear, shaft. It's these right here. Okay, that slides on a little bit easier. We're putting that little flange on this down. We're going to slide this all the way down, right? Boom, all the way down. Now it sets the right size there. This goes all the way down in there. Our motor, we need to put another motor on the shaft, so we'll take the next motor in the line. We need to line up the shaft, and then we'll squeeze the shaft on there. And the main difference in the filaments between this one and my other one, besides being a different brand, this is a Galaxy filament, so it's a filled, I'll say a filled. It's got some type of fill to it. I'm going to get that started, then use my Dipix and just slowly push it down on there. Again, being careful, going very, very slow. One, if you go real fast, you can either bend the shaft or you can split the gear, and you don't want to do either one of those things. So take your time, don't get in a hurry. And I would say read the manual. Oh, yeah. And I'm assuming based on the way that these are laying in there now, we'll want the wires to basically be going up. Oh, and I just noticed another change to these parts. I don't know if you can tell right there. There is a key slot there in the side for the front gearbox piece. So that's going to give you the correct depth alignment for where your gearbox sits. Tell you what, man, quality of life changes. Now we've got the wires in there. There are a couple, I'm assuming that these are zip tie holes for the wires. So I'm not sure if they're truly needed. Not sure if they're truly needed or if you can just bring your wires around and follow the gap there. I guess it'd be strain relief. Um, gonna say I know I had some zip ties here. Question is, are these too thick for these? MFWC the updated CAD. No, I'm using the CAD that I pulled down like 2 days ago. So it sounds like Armored Turtle just broke out the RTFM on me. Put out new CAD, you didn't look at it. These will be a little bit skinnier and easier. Go. You haven't pushed it yet, obsolete. Okay. So got our zip ties in there. So now our wires are properly run and out of the way. We're going to slide this in there, making sure that the gear's meshing. And 3x8. Again, just run it until it tightens up. You don't want it to be too tight. Grab your top piece there and put it on. And 3x8. Now with our wires down there in the proper place, we'll grab this and slide it on, making sure that it lines up over the motor as we flip it on so that we don't damage any wires. Then we'll take it back off because how I routed my wire Be careful that you don't bust your wires when you do this. Drain the wire. 3x8 to close this side. Just till you feel it snug. Your lever piece goes in. And 3x25 to hold the lever in place. Hey, Hutch Makerspace, how are you? Once again, just snug it up. Check your motion. And if you're that far away and your magnet's not pulling it, break these just a tad bit. It's not going to move that much, but you do want it to be able to move. Okay, so there's that. Now we need to put our wheels on. We reamed our wheels so that they should go on easier. Look at that. They go all the way in against the shafts, right? Those are all the way in against the shafts. And now these pieces, you're going to have to press in. So you're just pressing like the last little piece into these. Makes it a lot easier to get those on. And there's your front idler wheels. Okay. Now, what we would do is each lane, your idler is going to come down right here in the middle. Somehow, there we go. Get in there. Tight fit, by the way. So it's going to fit in there just like that. And you've got to put in 2 screws from each side. This is the part where it kind of gets to be a pain. And are these are more 8s, aren't they? I'm saying we'll be able to put a lane together, and then I'm out of screws unless I change. Do I have? Wait, these are 10s. We need 8s, right? How about for all these underneath ones and things that won't be visible, we'll just switch over and use these. Now this is where you'll see we have holes here. These are access holes on this piece right here for your screwdriver to get in. But you're going to have to kind of dump these down in there. Use your screwdriver to get in the head of the bolt and then line it up and drive it through. See what I'm doing there? And once again, I'm not ugga-dugga cranking for glory here. I'm just snugging them up and getting them in there. How's it going, Hutch's Makerspace? There we go. There's our first lane. And this is where I pretty much say, okay, this part is, I'll say, done and ready to install. Um, because the rest we can do once it's in the frame. So we'll be digging into that next one. So grab another set of parts. Need one of these, one of these. One of these. Put the little flange side down in our part. Put your rod through. Push it down so it bottoms out. That sets the space. Yeah, there we go. That sets the space. Go through the side that doesn't have the cutout is where this side goes. Come on. Make sure everything's spinning, that you're not getting any uh, pieces of overhang caught in the way there. We'll need our next motor. Pull our wires up because we know we're going to need to. We'll need our little printed part. D shaft line up. Get it started. 1 second, folks. Sorry about that, folks. That was my brother calling, wanting to know, like, I see you're not streaming. I'm like, really? I'm pretty sure I'm streaming. No drop frames. Yep, I'm streaming. So he's wondering when I'm getting there. Ay, ay, ay. This can go slowly. Make sure that you are lined up and not bending the gear or the shaft. Don't want to break it. And I can't reiterate, these are tiny, tiny, tiny motors. So be careful. Take your time. Line that motor up in that slot. Press it down in there. Go ahead and put the little top piece in there. Hold the motor in place. Go ahead and line this up. Like that. We'll go ahead and get our wiring routed through here. Yep, I appreciate it. Hopefully, we're going to get the rest of these built and then we'll probably call it. I'll need to go and recover the other one out of the freezer and see if we can't get those motors off to do the wire. If not, I'll have to figure something out. So I'm just getting my zip ties in here. Get the zip ties, not the wire, folks. We'll put the other side on, going slowly so that we don't damage the wires as they're connecting to the motors. Making sure things are lining up. Go. Once again, just till we feel the change in tension, slap that in place. It'll auto align. 3 by 25. Once again, just get in there. You want a nice actuating piece here. And then we'll take this and mount it in a lane. There we go. Couple of M3 by 8s. Why, oh why? There we go. Thanks a lot, Armored Turtle. Yeah, like I said, I'll go for just a few more minutes. I'll probably get the one more of these built. And then I'll have to go recover the one out of the freezer and try and see if I can't get those wheels off to route the wiring as appropriate. If I can, great. If I can't, then like I said, I'll have to pontificate on that while I'm at my brother's house for a few days. So there we go. Oh, you guys let me do that, didn't you? You guys watched me do that. What's missing? What can I not get on right now without taking it back out? We did nothing. Exactly. That's my point, Westry. You did nothing. You didn't tell me that I was not installing parts before putting this in place. Yeah, wheels are somewhat important. So I have done all, I'll say smooth TPU. I know some people are testing with fuzzy skin to see if fuzzy skin helps. Okay. One there. One here. Like I said, the wheels go on a lot smoother that way. Okay. And they do need to be pressed in pretty darn tightly. But it should be easier to get these in the second time. Well, preferably not having to do it a third, fourth, or fifth. Like I said, this black, orange, and red is looking pretty good, pretty seasonal for the upcoming fall and Halloween season, huh? So how many people here will be going to 3D Printopia? And how many are looking forward to seeing this live at 3D Printopia? You know I is learning, you know nothing. Uh-huh. Uh-huh. Where are these? I are learning, right? Okay. Nice thing is we're almost out of parts, so that means that we're close to being done, right? Yep, that looks about right. The side that doesn't have the opening for the end of the motor. Come on, I tested all of these. Here we go. There's that. We'll have this. We'll have the last motor. Slotted down in there appropriately. Our little top piece. Oh, I see, you guys are going to let me do it again. I'm trying to get ahead of myself. We need to put our gear on the shaft first. before we get ourselves in a world of hurt. You're not going, Timor? Uh-oh. Yeah, don't try and go fast. Go slow. Take your time. Don't be a know-it-all just because you've built a couple of these already. Okay. Now we'll put this back in there. Do I get better gear, bigger beds, one piece helmet? Yeah. Um, Depending on the helmet size, like if you're doing, say, like a kid, you could probably do that just fine on a 300 size printer. But if you're going to be doing a grown adult, yeah, you're probably going to want a 350 printer. Where's the lever for the assembly line? That's just me. I am the assembly line. Oh, got a couple of these already. And yeah, about the time I start going through here and I'm like, all right, I'm getting this now. It's coming routine. Like, all right, I'm done with this one. And there was a guy on YouTube that does a bunch of Arduino projects. And one of the Arduino projects is a wire cutter. So it literally will go through and you program in and say, I need 50 of these at this length. And it'll go and cut you 50 of those at that length. Right. So you could sit here and do, like, if we know the exact sizes, then we can go through and set up something like that and do, cut the wires, and then we can at least have pre-cut, or somebody can then go and make the, wire bundles. I thought about doing some things like that, and I'm like, yeah, but I'm not doing bulk stuff. And then I start doing things like this, and I'm like, so maybe I could do some bulk stuff. But yeah, no, that would be more for manufacturing type stuff, small batch work. We've been watching this project on Armored Turtle Stream. So much sturdier looking than, yeah. It, I tell you, it feels a lot more sturdier than ERCFA V2. And quite honestly, I'm not going to be playing with ERCFA for a little bit because, well, this is the board out of my ERCFA too. I've got 2 more of these on order. So that gives you any indication. One could be used to put back over on the ERCFA, or I could just I like that. Or I could just God, words are hard sometimes. I could just replace it out and put box turtles on all of my morons. Which is, I bet, the way that Rob would want me to do it. All right, so there's another one. We'll grab another lane and slide this down in place. Come on. I don't know why it feels tight. It's tight in this portion of it right here. Doesn't feel like a print tolerance issue either because it goes together well. Just like it wants to be in a very, very specific position before it drops in. Yeah, so I have a trad rack that I need to get up and running as well. Basically, I need to rebuild it with the latest parts. And I currently have it set up as like a 13 lane. And I'm gonna redo it as maybe a 4 or 5. Yeah, it's cool having that many lanes, but because you can, are you ever going to use them all? Right? Because at least this way, you could set up a shelf system and stack them up, right? But on a trad rack where you've got 12 lanes side by side, you've got to figure out what to do with your spools. And like you said, then you would also have to have a buffer system. Same thing with ERCFA. Ooh, I've got a 12 lane ERCFA. Well, that's great. Am I ever going to put 12 lanes in the ERCFA? Or 12 spools, let me rephrase that. Am I ever going to run 12 spools in the ERCFA? Probably not. Just because that, how are you going to manage all those spools and a buffer and, give me a second. I'm going to run downstairs and grab that piece out of the freezer and see if freezing that steel rod helps. And I will say it did not help. It did not help. Yeah, I don't know, because that is the only place where that wire can exit. And I don't think I'm going to be able to get in there to fish the wire around. Well, maybe. It'll be fun to try and get these rods fully seated again, or fully seated, period, but if I can get this center piece out, can I, at the very least, route these wires back through there? I won't be able to zip tie them, but if I can at least get the wires routed down through the channel, that'll help, right? Because otherwise I'm going to have to take some different drastic measures here. Okay, so we're not zip tied, but we're at least we've got the wires through there. So if I can manage to get the rods the rest of the way on, we can recover from this. Oh, it's it. I might have to clamp that. I may have to use a clamp on that. Actually, I don't think I have a clamp big enough for that. All right, folks, I'm going to have to work on this one after stream. We will have shafts that are going to go through here as well and into these ones, which I will ream as well to make it easier. You had to Dremel off an idler wheel and redo it? Exactly. We have to vacuum up here. All right. So now these wheels are going to, or these pieces are going to go on each side. Push them on there. They will self-center to a degree. How's it going, tugboat? The reamer works better than the drill bit for specific reasons. One, the drill bit pulls itself in. So on something like this, where it's not a through hole, if you try and open this up with a drill, chances are you're going to drill right through the bottom, right? The other thing is a drill, unless it's a extremely high quality drill, is not necessarily going to leave a concentric hole where a reamer will. All righty. Seriously, we're going to play this game again. Ow, that hurt. There we go. Started to pull back the nail on both thumbs. And so the way these will work is they'll slide in here and they'll lock with your little tab. Find that we gotta kind of get a little bend started, and then they'll be a little more rigid. But this way, you can put your spool in here, and it'll hold it in place. Once you get some weight on it, it's not going to move around. And then let me get this clamped. I'll do that off stream. We've got this stuff ready to go. Okay, so next stream, we will be building the frame. And as part of building the frame, we'll start putting all of our lane stuff together and installing our MMB, like physical install and stuff like that, and start doing our wiring. So, and I will show you all how I do the wiring and how I do it to try and keep the wiring as neat as possible. It's not the way everybody does it. Everybody is going to do it their own way. I may sit there and go, my wiring's great, and other people are like, hold my beer, you know? We'll have a few more end stops to do, but the end stops that we'll do will get mounted right here on another piece, so we can do those later. We don't have to do those right now. That's why I'm choosing not to do them right now. But yeah, that's kind of where we're at and where we're going to stop for the day. Like I said, I will try and get that squeezed together, probably using a clamp, and then I will get it mounted between now and the next stream day. I may stream on Monday. I will definitely stream on Tuesday, but I may stream on Monday as well. So keep an eye out, keep an ear out. And for the next stream, of course, I will always announce it on Twitter and Twitch and all that. So, yeah, it's not very difficult. It's, really the extruders, very, very simple for these extruders, right? Um, if you've built extruders in the past, once again, very simple mechanism. Um, I still think there might be the ability to shrink it down a little bit, but maybe not. Um, but the nice thing is we've got all the components built. We've built our extruders, we've built our idlers, we've built our e-spoolers, and we've got our wiring done or wired up the motors. We'll do the end stops later on. We'll have a couple of other wires to build for the motor board to connect the two boards together. And yeah, it gets, now that we have all the parts together, doing the frame, everything goes together real quick, right? And I may reprint the corner pieces because I do not plan on putting lights in any of the corners, even though there's a provision for it. But I do not plan on installing those. But we got to put some heat sets in here. Maybe we'll do that real fast, make up the next few minutes. Does anybody have a raid target that they would be interested in seeing today? Anybody up? Anybody new that somebody would want to see? So one thing, because I've already built this, when you get the MOSFETi, it has your screw down terminals and everything, and you have to solder them up yourself. Solder the 4 motor outputs with the screw terminals facing the outer edge of the board. On the input, this is the power input, have this facing the same direction. You do not want it facing down towards the side of the board. Normally that's what you want, but with the way it sits right here, you won't have a good connection for your wires if you're using a ferrule. So I had to desolder this, buy some new ones of these because I melted it, getting it undone, and then put one in with the ferrules facing up. It'll also make maintenance a little bit easier as well. And then this is installed with like M2 by 6 or M2 by 8 screws. And on this particular piece here, which is going to be the mount for the MMB, you'll put in 2 heat set inserts. And that will be to attach the board. The other 2 holes are going to be through holes. So the top 2 holes, you'll actually mount they'll go through and it'll mount the board, and you'll have the hammerhead T-nuts to mount it to your extrusion, right? What did I do with the board? There it is. So your MMB, when it goes on the mount, you want the lower side to be where all of your end stop positions would be. And it does not matter if you use socket head or cap head screws here. We're going to use some M3x6 socket heads because I have a 2.5 driver here already that'll work with them. And I will say, we'll look at the process. This board, because I had ERCFA on it, it's already got CAN bus set up. It's already got Clipper firmware on it. I don't need to go back through and redo that. But what I will say is your boot and reset buttons are down here at the very bottom. So once again, say this is one of your lanes, it's going to be mounted like right here. And this is the open bottom. So trying to get to the boot and reset pins is going to be very painful. So you need to do that to put it into DFU mode to put catapult on here. Or if you plan on just doing serial, then you'll run your 24-volt power in here and you'll run a serial cable. If you're going to run CAN bus, then you need to, rather than just put Clipper on here, you'll put catapult on here. Once again, either way, you still need to put it into DFU mode. So it would be hold down boot, click reset, let go of boot. You'll go into DFU mode, and then you can put your firmware on here. Once you're into catapult, then you can remove the jumper. You'd have a jumper here on your 5-volt pins. That says power the board with 5 volt from your serial. When you're done, you would take this, move it over to the other jumper, which is the 120 resistor for your CAN bus. You wire it up CAN bus. Now you're powering everything through your 24 volt, and you can flash Clipper on here through CAN boot that way. Once again, this is already set up, and I probably won't go into the full setup because there's plenty of good documentation out there, and it's going to depend on whether you're using an MMB or a an AFC light or what have you. But yeah, gang, that's where we're going to leave it. We'll come back, like I said, Monday or Tuesday, and we should have this done fairly quickly. Like this week, it will be done. And then we'll have to take down one of the tool heads over here, rebuild it using the Filomatrix system. And at the very least, we would have to redo the top portion and add a filament runout scissor. So at the very least, so the lower portion here has some changes to allow for the cutting arm and the cutter, right? So this will go in there, and this would allow for a filament cutter, right? This would have some modifications to it. Technically, you don't need the filament cutter. You can do standard tip forming, right? Oh, I have one of the plunger style solder suckers, and I was using solder wick and flux, and it just was not coming out. I don't know if I just soldered it really, really good. But this part, if you redo just the top part, the Filomatrix, then you will have, once again, the standard ball and end stop right here, and you can do one before the gears, and you can do another ball and end stop right here beneath the gears. And with those two, you can start really getting some good information out of your tool head, because what we're going to use so right now for AFC is the top one because that's going to enable us to know that we're at the extruder gear, we're at the tool head, right? Then the next one, if you do the bottom one, you'll be able to tell where the filament's retracting to. And once you know that distance, your cutter's right here. So you can minimize how much of the filament you're actually cutting during a tool change. Because you'd pull it down, you would cut it, you would push it back down into the hot zone, then retract your filament real fast. And that way you don't have a clog in the cold side of your hot end. So, but we'll do one of these. Well, we'll do two of them because I'll have one that'll go on. The plan is the parts I just showed you are the fluorescent red that will go on Iron Dragon, right? So the fluorescent red parts will go back here on Iron Dragon, the Trident. And over here, I've got the purple parts to replace the tool head in Fey Dragon. So I had to go get this filament. It came in the other day and I reprinted all the parts. This is Polymaker Purple ASA. So a few things left to build. We're making good progress though, so that's good. We do use 4 motors. Once again, the ERCFA only uses 2. I've got more motors over there, so we'll add the other 2 chips. And then we'll be able to start getting things assembled into the frame. And I'll kind of show you, walk you through how I run my wiring. I haven't had too many problems with the cutter when I was doing Happy Hair on the ERCFA. That part was working. What wasn't working was the actual consistency in loading and unloading filament at the servo and the servo positioning as well. The nice thing here, no servos whatsoever, none. We've got very simple extruders that everybody and their brother has been using for years if you've been 3D printing. And we got the N20 motors to help with the buffer rewinding of the filament. It's not used to load the filament, it's used just to unload the filament. Yeah, that's kind of where we're at. So thank you very much, everybody, for being here. Oh yeah, there's a plethora of printers behind me. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the rat rig. There's 2 rooks and the V0 on the dining room table. That's 16. The 0G Mercury 1, that is the Ender 5 Plus rebuild. Prusa Mini and the Trident 350 on a second table in the dining room. The Ender belt. So now we're up to 20. And 2 Ender wires in the spare bedroom. Not to mention the 6 or 7 that are over at Site B, known as Evil Diesel's house. So let me switch over to this camera. So black box sitting on top of black stack. Black stack is a rolling cart made of 2020. Let me see if I can move this some. Oh, tell you, this thing's a beast. So it's a rolling cart made out of 2020. And in the left side of that cart, there will be a e-dry filament dryer that looks similar to like a mini fridge. Okay. So that will sit up underneath there. It will have panels around the side and back. Right now, I'm still trying to source some decent 1/8 inch ACM panels. The first one I got, I could have used it to replace a fender on a car. It was so bent by Amazon. So I may talk to Chris and see if he can bring me some ACM panels, even if it's just standard outer dimension pre-cut, and I can locate and drill all the holes myself. Um, and then this is the door of the rat rig, and that just there's a couple of printed ledges, so you just set the bottom on the ledge and line it up, and it just um, goes on with magnets. You might need an intervention. I don't need an intervention. My wife says I just need to sell some printers, which in the works. In the works. I've got some. I've got some people that are trying to make some decisions on some printers right now. So, but yeah, thank you everybody for being here. It's a little bit after 2. I'm gonna bag out when I get back from visiting family. I'll try and get this pressed in there. Like I said, it's just a tight fit. Um, I should have reamed these out. I knew better. It's my own fault. But hopefully I can get this squeezed together with some clamps without breaking pieces. And then I'll get this installed in the lane so that we'll be ready to actually get going from that point on. Yes, you need to finish your rook, and I know I owe you a wiring diagram. I owe you a wiring diagram. Um, but folks, thank you very much for being here. Thank you for hanging out with me. I'm going to go ahead and get off here so that so I can go and do the whole family thing. I need to see who we can raid out to today. Not sure what options we have. We've got Bricks O'Brien, Free Heathen, Stephen Poole. I think he's just showing printers. Mayhem just showing printers. Maker Deck, Boxin, Ugly Moo. Looks like he's doing some painting of miniatures. Ryan Cleveland, he's fishing. Chris Perillo, but I don't actually see him. Can't really get. Oh, not a problem. Not a problem. For the next, that's why I do this. Is one, I'm going to be doing it anyhow, and two, just being able to talk my way through it, show you guys things, show you guys that yes, I am human just like everybody else. I do make mistakes. I do have to then do some creative problem solving and things of that nature. Um, it happens, right? It happens. But thank you all very much for being here. I'm going to go ahead and get a raid. Let's jump over to um, go over to Ugly Moo. Like I said, he was doing some painting. He paints miniatures, um, Warhammer, and all kinds of things. It looks like he's doing like a baby Deadpool. So let's go over and hang out and check out Ugly Moo and watch some of his good painting skills. Uh, Once again, thank you everybody for being here. I'll let you know when the next stream is. And yeah, just remember it's September. You want to see me feel the pain? Uh, let's get some subs and let's get subs, do raid trains, all that good stuff, and you'll see me have to dig in and feel the pain. So take care, everybody. Have a great weekend. This is a holiday weekend. Take the time off, relax, enjoy. Bye now.